In this video, we're going to be trying to draw the graph of this polynomial. So the first thing that we're going to do is to find the first derivative of this polynomial. So the first derivative is just going to be 3x squared plus 2x minus 1. Yeah. So to find where this graph is going to be positive or negative, we are going to construct a table of values, right? Yeah, so to construct that table of values, we have to first factorize this. So it's just going to be positive. Yeah, so by factorizing this polynomial, like the first derivative, right, we have found three intervals, which is x less than -1, and then between -1 and 1/3, and then greater than 1/3. So you test the values of the x's in these intervals, and then you see where the first derivative is positive, negative. Yeah, so we've got the first derivative positive in these two regions and negative in this region, which just says that it's just going to be increasing in these two intervals and decreasing in this interval. Yeah. So after that, what we have to do is to find the second derivative again. So the second derivative is just going to be 6x plus 2. Yeah, that's the second derivative. Yeah, so to test for concativity, like we did, we derived the second derivative formula, and then we found it as 6x plus 2. Then we equate that to 0, we find x is equal to -1/3. So we take the left side and the right side of -1/3, and then we put the values like to the extreme left or to the extreme right. So to the extreme left of -1/3, let's just take a value of -2, and we put it in our second derivative function, which is just going to be 6 -2 plus 2, which is -12 plus 2, which is equals to -10, which is less than 0. So it means that in this region is going to be concave down. So for this region, the other region, we're going to take a value which is greater than -1/3, which is 2. So it's just going to be 2 plus 2, which is 12 plus 2, which is 14, which means that it's concave up since it's greater than 0. Yeah, so this is the graph of the function with the inflection point here where concativity changes suddenly, and then these are the minimum. No, yeah, this is the local maximum and the local minimum, and then yeah, that's all.